I welcome you all in this lecture of the vector calculus. Today I will solve few more questions based on directional derivative, and then I will define divergence and curl of a vector. So our questions are, first of all, find the directional derivative of the function x square minus y square plus 2z square at the point P 1, 2, 3 in the direction of the line PQ, where your Q is 504, where your Q is equal to 504. So solution, let us calculate grad f. So grad f will be I del upon del x plus j del upon del y plus k del by del z of x square minus y square plus 2z square. Now if you differentiate this bracket with respect to x, then we will have 2xi minus 2yj, then we will have 4zk. Now this is your grad f. So we have to calculate this grad f at this point 1, 2, 3. So grad f at the point 1, 2, 3 will be equal to, your x is 1, so this will be your 2i, your y is 2, so this is your 4j, your z is 3, so this will be 12k. Now as we have to find out the directional derivative in the direction of p, so let us find out the vector in the direction of pq. So let b is the vector which is your direction pq, then this will be your OQ minus OP, where OQ is the position of the vector Q. So your Q is 5i plus 0j plus 4k, then your P is I plus 2j plus 3k. So the direction is 4i minus 2j plus k. So this is the direction. Now let us find out the directional derivative. So your directional derivative will be equal to grad f dot your v cap. So grad f is 2i minus 4j plus 12k into the unit vector. So the unit vector will be 4i minus 2j plus k divided by square root of, this is your 16 plus 4, 20 plus 1. So this is equal to 21. Now we can write it as I dot I is 1, so we have 8, j dot j is 1, so we have again 8, and your k dot k is 1, so we have 12 upon square root of 21. So this is equal to 28 upon the square root of 21, or if you multiply the numerator by square root of 21, then this is your 28 square root of 21 upon your 21. And you can further write it as 0 4 is 28, so this will be 4 root 21 upon 3. So this is your directional derivative of the function f in the direction of the line PQ. Now our next question is, to find out the directional derivative. Find the directional derivative of f, which is your ax square y plus by square z plus c x square z, y square z, a x square y plus b y square z, and then c x square z. Okay, we have to find out the directional derivative of this phi at the point 1, 1, having maximum value 15 in the direction parallel to the line x minus 1.2 equal to y minus 3 upon minus 2 and z equal to 1. So here we have to evaluate the directional derivative of f at this point in the direction parallel to this line, and it is also given that the maximum value of this directional derivative is your 15 and your maximum value is mod of grad f. So solution, let us find out grad f. So your grad f will be equal to, differentiate this with respect to x. So if you differentiate this bracket with respect to x, then we will have 2axy. Grad f is basically I del by del x plus j del by del y plus k del by del z of this bracket f. Now in the bracket in f we have two components of x. One is ax square y, then another is cx square z. So the differentiation with respect to x will give you 2axy, then 2cxz. Then we will have j times differentiation with respect to y will be equal to, I think there is some mistake. The first term is equal to this has to be cz square, cxz square. Now, so if you differentiate this one with respect to x, then this will be a cz square. Then the differentiation with respect to y will give you 2byz plus differentiation with respect to y is equal to plus ax square. Then your differentiation with respect to z will be by square of 2cxz plus by square. Okay, this is your grad f. Now let us find out the grad f at point 1, 1. So grad f at 1, 1 is equal to, now this will be your 2a plus c plus j times 2b plus a plus k times 2c plus b. Now it is given that its maximum value is 15. So maximum magnitude means, so maximum value of directional derivative is equal to mod of grad phi, and it is given that it is equal to 15. So 15 equal to, now the modulus of this one will be 2a plus c whole square plus 2b plus a whole square plus 2c plus b whole square. Now it is equal to a plus 2b whole square, b plus 2c whole square, and then c plus 2a whole square equal to 225. So this is equation number 1. So we have this equation. Now again it is given that, now this is also the direction of directional derivative, because we know that the maximum value occurs in this direction. The maximum value is mod of grad f, and this maximum value occurs in the direction of grad f. Now here it is given that the directional derivative have maximum value 15 in the direction parallel to this line. As the direction of maximum value is grade f and it is parallel to this line, so that means your direction ratios will be equal to each other. Hence, as maximum value of grade f is parallel to the line, parallel to the given line, hence their reduction ratios will be common, so we can write here we have 2a plus c, the component of y, and here we have 2. So this is equal to 2b plus a upon minus 2 and then 2c plus b upon 1. Say this is your first and this is your second and this is your third. So first and second implied, so this will be your 2a plus c equal to minus 2b plus a. So from here we have 3a plus 2b plus c equal to 0. So this is equation number 2. And similarly we will have from this equation we will have a minus 2b plus, so this will be a plus 4b minus 4c, so we have 4c equal to 0. So this is equation number 3. Now the values of a and b is given by, now your a will be 4 to the 8 minus 4, so this will be your 8 minus 4, then we have minus sign, this will be 12 minus 1, we have the component of c in the equation here, this is your, okay, 2a plus c equal to minus 2b plus a, so this will be your 3a plus 2 plus c. Okay, then we will have minus b and then this 12 minus 1 and then finally c upon 12 minus 2. Sure. Let us assume that this is equal to k, so our a is equal to 8 minus 4 will be 4k and our b will be equal to minus 11k and your c is equal to 10k. So we have the values of a, b and c. Now let us put this a, b, c in equation number 1. So equation number 1 implies, so from here equation number 1 will give you, so from equation number 1, now if you put a equal to 4k and b equal to 11k minus 11k, so this is your 4k, then we will have minus 22k. So this will be your 4k minus 22k, that means minus 18k. So by equation number 1 we have 18k whole square plus, again this is your b plus 2c. So b is minus 11 and c will be 20. So minus 11 plus 20 will give you 9k. Then we will have c plus 2a. So c is 10 plus 2a means 18. So again the third term will be 18k whole square. It is equal to 225. Now this is equal to 324k square plus 81k square plus 324k square equal to 225. Now if you add this left hand side, then this will be your 4 plus 1 plus 4. So we have 9. Then we will have 10 plus 2. So we have 729. K square equal to 225. This is your 5 plus 4, 9. Then we will have 2 plus 8. So 10 plus 2, 12. Then we will have 3, 3, 6, 7, 2, 9. So from here our K will be plus minus 225 upon 729, and this is equal to plus minus, this will be over 15 and this will be over 27. So it is equal to plus minus 5/9. So this is your k. Now your k is 5/9. So from here we have the values of a, b and c. So therefore we have to, what is our question? We have to evaluate the values of a, b, c. We have to evaluate the values of a, b and c. This was the question is, if the directional derivative of this is maximum at maximum value is 15 in the direction parallel to this, then find a, b, c. This was your question. So our a, therefore our a is equal to 4 times k. So this means plus minus 20/9. Your b will be equal to minus 11 times k. So this will be your again plus minus 55/9. Your c will be equal to 50/9. So this is your a, b and c. Now let us define divergence of a vector point function. So divergence of a vector function point function vxyz, or just write v, is given by, we write divergence of v as div of v, and so divergence of a vector point function which is continuously differentiable, of a point, divergence of a vector point function v which is continuously differentiable is given by divergence of v, and this is equal to del dot v, and we have the notation for that. The value of del was I del by del x plus j del by del y plus k del by del z. Now this is equal to I del by del x plus j del by del y plus k del by del z, and at outside we have v. So this is equal to I dot v. So I dot v means we have I dot del v upon del x, then j dot del v upon del y, then we will have k dot del v upon del z. So this is, and we can also write it as I dot del v upon del x. So your divergence of v will be equal to I dot del v upon del x. Now if you write v in the component form, if v equal to v1i plus v2j plus v3k, then our divergence v will be equal to, now your divergence v is equal to del dot v, put the value of del which is your I del by del x plus j del by del y plus k del by del z, then we have the value of v as v1i plus v2j plus v3k. So as your I dot I is 1, so we have del v1 upon del x plus del v2 upon del y plus del v3 upon del z, and we can write it as summation del v1 upon del x. So this is your divergence. Now what is its physical meaning? Suppose that Vxyz is the velocity of a moving fluid, is the fluid motion, is the moving fluid, then the loss of fluid volume per unit time at point x, y, z is your divergence of V. So the loss of fluid per unit volume per unit time is your divergence V. That means we can also say that divergence V is basically the outward flux. Thus, divergence V is the outward flux at the point Pxy, at the point xy. Now, if your loss of the fluid per unit volume per unit time is 0, if loss of fluid per unit volume and per unit time is 0, then we say that divergence B of is equal to 0. So we say that divergence B equal to 0. And the vector for which your divergence B is equal to 0 are known as solenoidal vector. So the vector for which divergence B is equal to 0 is known as solenoidal vector. So the vector for which your divergence B is 0 is known as solenoidal vector. Now let us define curl of V. So this is your divergence of vector. Now let us define curl of a vector. So the curl of a vector point function V, which is continuously differentiable, is given by curl of V, and for that we will have cross sign here. So this is your vector product. So we have vector product here, then we will write cross product, then this is your I cross del V upon del X. So your curl of V is equal to summation I cross del V upon del X. Now if you write V in the component form, then your V will be B1I plus B2J plus V3K. So your curl of V in this case will be equal to, therefore curl V is equal to del cross V. Now your del cross V means your del is I del by del X, J del by del Y plus K del by del J into B1I plus B2J plus B3K. So this is equal to summation I, J, K, then we have del by del X, del by del Y, del by del Z, and then B1, B2, B3. So this is equal to I del B3 upon del Y minus del B2 upon del Z. Then we will have plus J. So plus J will be your del B1 upon del Z minus del B3 upon del X. Then your K will be equal to del B2 upon del X minus del B1 upon del Y. So this is your curl of a vector V. Now the physical interpretation so if V is the linear velocity of a point of a rigid body which rotates about a fixed axis, so if V is the linear velocity of a point of a rigid body which rotates about a fixed axis with angular velocity omega, then which rotates about a fixed axis with angular velocity omega, then your V is equal to half curl W. Then your V is equal to half curl W. And we also know that the relation between V and W is V is equal to omega cross R. So in this case, when your V is the linear velocity of a point of a rigid body which rotates about a fixed axis with angular velocity omega, then your curl of W is equal to 2 times V. Now suppose that the body does not rotate about this fixed axis. So if the body not rotate, then your curl of W will be equal to 0. So in that case, your curl of W will be equal to 0. Now if your curl of W equal to 0, then such type of vectors are known as your irrotational vector. So if the curl of vector W is 0, then if a curl of the vector W is 0, then the vector W is known as irrotational. In that case, the vector W is known as irrotational vector. So we have defined two type of vector here. One is your solenoidal vector and another is your irrotational vector. So for the solenoidal vector, we will have divergence of V equal to 0, and for the irrotational vector, we will have curl of W equal to 0. Now again, let us define conservative force or conservative field. A field F is said to be conservative if there exists a scalar function phi such that F equal to grad of phi. So if there exists a scalar function phi such that F equal to grad phi, then we will say that this vector field F is conservative. Now, if you want to calculate the curl of such vector, so the curl of F in this case will be equal to del cross del phi. So this is your curl grad phi, and later on I will prove that curl grad phi is equal to 0. So this is equal to 0. So that means we can say that for a conservative field, our curl of the vector will be equal to 0. So your curl of F equal to 0. Also, if you want to evaluate this phi, as we have to find out this phi, because F will be conservative if there exists a function phi for which this condition is satisfied. So let us try to find out this phi. So your F dot dr will be equal to, your F is grad phi. So we have grad phi dot dr. Your grad phi I del phi upon del x plus j del phi upon del y plus k del phi upon del z. This is your grad phi, and then dot dr is dxi plus dyj plus dzk. Now this is equal to del phi upon del x into dx. Then we will have del phi upon del y into dy, then del phi upon del z into dz. Okay, and this is your definition of the total derivative. So this is equal to d of phi. So from here you can say that our d of phi is equal to f dot dr if the field is conservative. So this is equal to f dot dr. Now we can easily integrate this equation, and after integration we can have the value of phi. So if a particle rotates from, if a particle moves from P to Q, say P is x1, y1, z1 to Q, x2, y2, z2, then let us integrate this equation now. So after integration we will have in the left hand side the limits from P to Q, and in the right hand side we will have this line integral. So the value of this line integral in this case is equal to, so the value of this line integral is in this case will be equal to phi at Q minus phi at P. So but this is true only when your force or your field is conservative. So if your field is conservative, then this line integral is equal to phi Q minus phi P, where your Q is this point and P is this one. So that means with the help of this method we can evaluate our line integral. So next question, our question is calculate, find divergence V and curl V for the vector V equal to x y z I plus 3x square yj plus xz square minus y square zk at the point 2 minus 1 1. So let us find out the value of divergence V and curl V for this vector at this point 2 minus 1 1. So solution, divergence V is equal to del dot V, and V has 3 components, so this is equal to, just put the values of V. You can also write directly it as del V1 upon del x, del V2 upon del y, and del V3 upon del z, where your V1 is the first component of V, which is your x, y, z. So this is your del by del x of x, y, z. Then you will have del by del y, V2. V2 means the second component, 3x square y. Then del by del z of V3. V3 means the third component. So this is equal to, now partial differentiation with respect to x will give you yz. From here we will have 3x square, and from here the differentiation with respect to z will be 2xz minus y square. So the value of divergence B at the point 2 minus 1 1 is equal to, now your x is 2, y is minus 1 and z is 1, so this will be your minus 1. Then we will have 3 into x square, so this will be your 12. Then we have 2 times xz, so 2 times x is 2, z is 2, so this will be your 4 minus y square, that means 1. So this is equal to, this will be your 3 plus 12, so 15 minus 1, so 14. So your divergence of B is equal to 14. Now your curl of B is equal to del cross B, and this is equal to I, J, K, del by del x, del by del y, and del by del z. Your B1 is the first component x, y, z. Then we have the component 3x square y, and the third component is x z square minus y square x, y square z. So, and this is equal to I times del by del y of this bracket, and that is equal to partial differentiation with respect to y will give you minus 2yz, then we will have minus sign, differentiation with respect to z will be 0, then we have minus j, differentiation of this with respect to x will give you z square, then differentiation of this with respect to z will give you xy. Then we have a differentiation of this with respect to x will give you 6xy, and again differentiation with respect to y will give you xz. So just put the value of xyz, which is equal to minus 1, 1. So this is equal to I times, put the value of y minus 1 and z as 1. So this will be your plus 2i. So this is your 2i. Then this will be your z square, so that is your 1. And this will be your x is 2, y is minus 1, so we have plus 2 plus 1. So this is 3j. And you put third term will be, put x as 2 and y as minus 1, so this will be minus 6. And here we will have this x into z will be minus 2. So 6 into this third term will be your differentiation with respect to x. Differentiation with respect to x will give you 6xy. Then we will have minus xz. So this is equal to 6 into x. So this is 12 minus 12. Then minus 2. So this will be minus 14. So minus 14k. So this is your curl of the vector v. Now next question is, find a for which your vector v is equal to 2x square y plus yzi plus xy square minus xz square j plus axyz minus 2x square y k is solenoid. So here we have to find out the value of the vector a for which this vector is solenoid. As this vector is solenoid, so our divergence v will be 0. As divergence as v is solenoid, so this implies divergence v equal to 0. So if the divergence of v equal to 0, then your del v1 upon del x, del v2 upon del y, then del v3 upon del z is equal to 0. So now if these three are equal to 0, then del v1 upon del x means the differentiation of v1 with respect to x. So this will give you 4xy. Then del v2 upon del y will give you 2xy. Then the differentiation of third term with respect to z will give you axy minus axy, and it is equal to 0. So we have to find out the value of this vector, find a for which this is solenoid. Now at the point 1, 1, 1. So at our x, y, z are 1, 1, 1. So we have 4 plus 2 plus a equal to 0. So from here we have a equal to minus 6. So the value of a is minus 6 for which this vector is solenoid. Thank you so much for joining this lecture.